Here's a normal distribution problem. So the weights of 6-month-old kittens is normally distributed with a mean of 6.3 pounds and a standard deviation of 2.1 pounds. So notice that before we continue on with the problems, there's a couple keywords here. We see the word normally distributed. We see the word mean of this and standard deviation of this. So if I were to write it in probability notation or in X is distributed normal with a mean of 6.3 and a standard deviation of 2.1. Okay, so do write this. Sometimes I will ask you to write this out, or sometimes you just have to write it out. So this kind of tells you if X is the weights of kittens, of 6-month-old kittens, then you know that it's going to be normal with a mean of mu equals 6.3 and a sigma of 2.1. Okay, so here part A says find the probability that a randomly selected 6-month-old kitten weighs less than 5 pounds. So let's go ahead and draw a picture of this. So here's my picture. Here's all of the weights of all the possible kittens. The mean is 6.3. And then we want the probability that a randomly 6-month-old kitten weighs less than 5 pounds. So 5 is around here. So 5 is less than 6.3, so that's why it's off to the left. And we want it to be less than that. So everything that's less than that is going to be all of this area. Okay, so if I suppose that this is going to be negative infinity, okay, and here's positive infinity, what we got to figure out is what is going to be this area. Now, since we have the value of X and we're finding the probability, we have to use normal CDF. So we're going to use normal CDF. My lower bound in this case is going to be this bottom part because this is going to be all of this area. The lower part is going to be my lower bound, which is going to be negative infinity. My upper bound, which is the highest point of this particular area, shaded area, is going to be 5. Okay. My mean, mu, is going to be equal to, well, that's going to be 6.3. And then my sigma, standard deviation, is going to be 2.1. So we're going to put this into our calculator. So what we're going to get is second data, distributions, normal CDF. The mean in this case was equal to, I forgot what it was, 6.3. And then sigma is going to be 2.1. Then our lower bound is going to be equal to negative infinity, so we're going to leave it there. And my upper bound is going to be equal to 5, so we're going to change that to 5. Then we're going to calculate, and that's going to give us 0.2679. Okay, so basically, if you want to put this into context, this area is 26.79%. So the chance that you will encounter a 6-month-old kitten that weighs less than 5 pounds is basically about a 26% chance. Okay. All right, now let's go to the next problem. Okay. Find the probability that a randomly selected 6-month-old kitten weighs at least 8 pounds. Okay, so what does at least mean? Well, let's first start off with drawing my graph. You know that the mean is going to be 6.3. Okay, 8 is right here. So remember, at least means greater than. And if you forgot that, just go ahead and go to the little cheat sheet that I have. You'll see that it's going to be greater than. Because if I'm at least 8, that means it's 8 or more. So we're actually looking for all of this area. So here it's going to be positive infinity. Okay. So we know that we have the X value. We want to find the probability. So we're going to use normal CDF again. My lower bound is going to be the lowest point of this particular area, which in this case is 8. My highest point is going to be this positive infinity, so that's my upper bound. My mean, mu, is going to still stick as 0.3, and sigma is going to be 2.1. All right, so let's figure out what this guy is. Okay, so I'm going to go to this. So second data. Go to distributions, normal CDF. Still 6.3 is the mean, 2.1 is the sigma. Now my lower bound is going to be, what was it? I think it was 8. Yeah, 8. There was 8. And then I'm going to let my upper bound go to positive infinity. So we're going to press calculate, and we're going to get 0.2091. So it's going to be 0.2091. So there's about a 21% chance that you'll encounter a kitten that weighs at least 8 pounds. Okay, now let's do part C. So part C says, find the weight associated with the top 20%. So let's draw a normal curve again. So my mean is going to be 6.3. Now we're looking for the weight of the kitten associated with the percentage. Notice that we want the top part. So the top part is going to be 20%. So all of this guy is going to be 20%, which is basically 0.2. And we're looking for what weight is going to be associated with 0.2. Okay, so this means that now we're looking for this particular part. We're not using normal CDF. We're going to be using inverse norm. And if you remember, inverse norm, we're always looking for the area to the left. Now, in this case, we have the area to the right. So how can we figure out what this area is? Well, if this guy is 20%, the other part is going to be 80%. We want to figure out what this area is, which is 80%, which is going to be 0.8. So 0.8 is going to go here. My mean is still the same, still 6.3, and my sigma standard deviation is still 2.1. Okay, so what is this going to give me? So let's go ahead and go to my calculator. We're going to press inverse normal, second data, go to distributions, down to inverse normal. So this is going to be 0.8. My mean is going to be equal to 6.3, and then sigma is 2.1. So then it's going to be weight of 8.07. I'm going to say pounds. So a weight of 8.07 pounds is going to be associated with the top 20%. Okay. All right. So now let's do the last problem. So find the 30th percentile. Okay. So let's go ahead and draw a picture one more time. So my mean is still going to be 6.3. We're looking for the 30th percentile, which means that 30% of the data is going to be below it. So we're looking for what weight is going to be 30% below it. So there's 0.3 right here, okay, or basically 30%. Okay, so again, we're looking for the weight. So we're going to try to figure out using inverse normal. So our weight is going to be inverse normal. Remember, we want the area to the left. The area to the left is already given to you, so you don't have to subtract it from 100. So it's going to be still 0.3. My mean is going to be equal to 6.3, and my sigma is going to be equal to 2.1, because that was the standard deviation, right? Yes. Okay. So now let's go ahead and put this in our calculator. So we're going to press second data, down to distributions, inverse normal. And then we're going to do 0.3. Okay. I think it was 3, right? Yeah, 0.3. Okay. So 0.3, then 6.3 and 2.1. Okay. So that's going to give me, 5.19 or 5.2. Okay. So 5.2 pounds. So basically a kitten that is 5.2 pounds is going to be on the 30th percentile. Okay. All right. So I want you guys to make sure that you really understand this, because something like this will be on the exam. Be able to do regular normal CDF problems based on the given information. Usually with these problems, you will see these keywords: normally distributed, mean of something, standard deviation of something. And then you'll be able to do have these problems, and you have to decide, is this a normal CDF problem or is this an inverse normal problem? Okay.